Hey, this is the first analytical geometry question, and here we go. Let's do the first few, or let's see how long we get the first few done. In the diagram below, they give a bunch of points around here. They give us B, they give us A. They tell us about that this thing is a parallelogram. So what I did is I put parallel little lines on here so it reminded me what was going on. And point D lies on the x-axis, and the equation BC equals 2y minus x equals 14. That's the equation that goes through here, the equation that passes through BC. Okay. Now, the first question they asked is determine the equation of the line AD. Determine the equation of that line. Well, we know it's parallel, so it's got the same gradient as this one. But the problem is this isn't in the right form to look at the gradient. We've got to make it y equals mx plus c. So what we do is we take this thing and we add x and we divide by 2. 14 divided, and there it is. Y equals a half x plus 7. That's what the equation of this line is. So is this, but that's in the form y equals mx plus c. Well, now we've got the gradient. Because it's parallel, it has the same gradient. So it's y equals a half x plus a different y-intercept than the line BC has. So all we have to do is take x is 1, put that in there, 5 in for y, and then solve it. And then you get, that's a half. 5 minus a half is 4.5. I don't like writing it like that. That's for elementary school because it's just not so nice for algebra, I think. But I shouldn't criticize the memo like this. But I'd write 9 over 2, and we'll see in the next question why that's a good idea. Show that the coordinates of D are minus 9 and 0. Well, look, we've got the equation of the line. There it is. Y equals a half x plus 4.5. So all we have to do is let y equal 0 to find this x-intercept here. So we go 0 equals a half x plus 4.5. Then we subtract 4.5, but we know that 4.5 is really minus 9 over 2. Now, if we multiply everything by 2 here, the 2's will cancel, and we'll get x equals minus 9. So x is minus 9, and y is 0. And there we go. That's the coordinates of, let's try the next question. I don't think it's been too long. Show that DF is perpendicular to BC, show that DF is perpendicular to BC if the coordinates are minus 10 and 2. So, okay, well, let's try this. We go minus 10 and 2 and minus 9 and 0. We find the gradient, and we get it's equal to negative 2. Well, that gradient of negative 2, if we multiply it by the gradient of dA, the product of those gradients is minus 1. And if the products of two gradients are equal to minus 1, then DF is perpendicular to BC. You got to tell that whole story. You've got to say that the gradients multiply to equal negative 1. The negative 2 times a half equals minus 1, and that's what makes it perpendicular.